Usually we drive circuits with signal frequencies. For instance, at the moment, I have a drive for a circuit that's at 20 hertz, and you can see that the frequency is unchanged as a function of time. It's just a uniform sine wave. And that's done by setting up the signal generator on its continuous mode of operation, this button at the top. But it's often useful to sweep the frequency, to have the frequency change from one frequency continuously to another frequency. And the signal generator can do that. Let's see how we would set it up. First of all, we would, as usual, run a cable from the signal generator over into the oscilloscope. And it's also important to set up auxiliary triggering when you're going to be running in this mode. So you would set up the output trigger from the signal generator into the auxiliary in and properly configure the trigger menu, something I've already done, so I won't show you that today. Now, the next thing is to change the mode of operation from continuous to sweep. So I just light up this light over here, and going back to the oscilloscope, let's see what happened. Now you can see that the frequency of the sine wave is changing. It starts out at a fairly low frequency, and then the frequency increases smoothly as we go across the screen. If I slow down the scale of the oscilloscope so that I can see multiple iterations of this time, what you'll be able to see in the moment is that this pattern repeats. It goes from a low frequency to a high frequency, then jumps abruptly back to the low frequency, and then builds up to that high frequency again. To get it to run in this mode, though, you do have to configure a bunch of things on the signal generator. The first thing to configure is the start frequency you're going to use. You can set that by pushing this top button over here, getting a start frequency. At the moment, I've already set this to be 20 hertz. We also need to configure a stop frequency, which is currently set at 100 hertz. Let's use that for the pattern. That's what we used for the pattern over there on the oscilloscope. And also the sweep time, how long it takes the signal to go from its low frequency end to the high frequency end. That's configured over here with the parameter, the sweep time. And that's, in our case, going to be set at 1 second for it to go all the way across. Now, in addition to that, one often wants to set the return time to 0 milliseconds, and there's one more setting that you might want to use. If we go back to the oscilloscope, you can see that this is changing in a logarithmic fashion from one side to the other. Let me go back to the faster time scale, and maybe this will be more obvious that the frequency is increasing logarithmically. But it's possible to set up the scope to have the frequency increase linearly. To do that, we have to go to the More menu over here, and we can change this button to a linear sweep. If we go back to the oscilloscope, the differences are subtle, but it's spending less time at the low frequency side when you've got it on the linear sweep. Now, in general, when you're exploring a filter behavior, you're interested in the logarithmic changes in the frequency. So in general, I would run the sweep on the logarithmic setting rather than the linear setting. Now that you understand how to set up sweep mode, let's actually use it to do something, to observe the behavior of a filter. I've increased the maximum frequency here up to 400 hertz to make things easier to see, and you can see we've now got a nice span on the input to our filter. And if I turn on the output of the filter, you can see the response easily. The output of the filter is definitely decreasing as the frequency goes up.